You are welcome to provide a solution given this nice exponential equation, which is 3 to power x plus 3 to power x plus 3 to power x. This is equal to 333. So what is the value of x? Solution here, 3 to power x is common. So we factor out 3 to power x so that we'll have 1 plus 1 plus 1. This is equal to 333. The second step here, we have 3 to power x multiplied by, this is 1 plus 1 plus 1, this is equal to 3. So this is equal to 333. So let's divide both sides by 3. So that here we'll have 3 to power x, this is equal to 111. Now, so for the value of x, we introduce the natural logarithm on both sides. So that we'll have log 3 to power x, this is equal to log 111. So log 3 to power x, this is in the form of log a to power n, which we can express as n log a. So applying this power rule property, we find that log 3 to power x becomes x log 3. This is equal to log 111. So let's divide both sides by log 3. By log 3. So let's simplify here log 3 and log 3 so that x is equal to log 111 divided by log 3. So we can express 111 as 37 times 3. So let's substitute this. So that means we'll have x equal to log 37 times 3 divided by log 3. So log 37 times 3, this is in the form of log a times b, which you can express as log a plus log b. So applying this logarithm property, then we'll have x is equal to log 37 divided by log 3 plus log 3 divided by log 3. Okay, so let's continue to simplify this. Now let's simplify here. Log 3 and log 3 simplifies so that this is 1. So that x is equal to 1 plus log 37 divided by log 3. So log 37 divided by log 3, this is in the form of log a divided by log b, which we can express as log a to base b. So let's apply this logarithm property so that here x is equal to 1 plus log 37 to base 3. So this is the value of x. So let's verify that this value of x satisfies the equation. So if you recall, we end that 3 to power x plus 3 to power x plus 3 to power x, this is equal to 333. Okay, now we simplify this further to 3 to power x, this is equal to 111. So let's check if 3 to power x is equal to 111. Okay, so here we'll have 3 to power x, x is equal to 1 plus log 37 to base 3. This should give us a value of 333. So the next step here, 3 to power 1 plus log 37 to base 3. This is of the form a to power n plus m, which you can express as a to power n multiplied by a to power m. So applying this property, then here we have 3 to power 1 times 3 to power log 37 to base 3. this is equal to 111. So this is supposed to be 111. Now let's verify that the value of x, which is 1 plus log 37 to base 3, actually satisfies the equation. Now, if you recall, we aimed at 3 to power x plus 3 to power x plus 3 to power x. This is equal to 333. But now since 3 to power x is common here, we factor out here. So this is 1 plus 1 plus 1. This is equal to 333. So here we'll have 3 to power x times, this is 1 plus 1 plus 1, this is 3. This is equal to 333. So let's divide both sides by 3 here. So that 3 to power x, this is equal to 111. So let's substitute the value of x. Here we'll have 3 to power 1 plus log that 7 to base 3. This should give us a value of 111. So since 3 to power 1 plus log that 7 to base 3, this is in the form of a to power n plus m, which we can express as a to power n multiplied by a to power m. So applying this exponent property, then this means that you'll have 3 to power 1 times 3 to power log that 7 to base 3, which will give us a value of 111. That is 111. So from here, so 3 to power log that 7 to base 3, this is in the form of m to power log a to base m, which is equal to a. So applying this property, then we'll have 3 to power log that 7 to base 3. This should give us a value of 37. Substituting this value of that 7, then we have 3 multiplied by that 7. This should give us a value of 111. So that 7 times 3, this is 111. And this means that the left-hand side is equal to the right-hand side. And that affirms that the value of x, which is 1 plus log that 7 to base 3, actually satisfies the equation. So kindly follow the steps, like this video, and subscribe.